Just making sure right now that my stream is up and running. Let's see. All right, that's running. But Twitch, it's running on YouTube. All right, looks like it's all right. We're live. Just gonna solve a few easy and medium Leetcode problems just for practice or whatnot. I've been busy with a lot of other coding work. Let's get into it. The classic problem: reverse linked list. Given the head of a singly linked list, reverse the list and return the reverse list. So the main idea here is that we have a node and next points to the next node. That's why they gave us the definition over here. So what we can do is keep track of the previous node, current node, and the next node, right? Because we have to switch the pointers. This is a classic problem. I think they used to ask this like in Microsoft like 10-15 years ago, right? So if we have nodes like this, right, each node is the definition that has value and next, so we need to reverse it. So we need a way to track the current node and then previous node. So let's say previous, next. For now we'll set them to none, and then our current node is going to be head. So we can just traverse through the whole thing until we hit null or none in Python. So while current, right, so the first thing is we need to capture next node, right? So let's do this. Next. So this will reference, in this case, if it's starting with 1, will reference 2. Right, that's going to be our next. I think I have the lim keys enabled, but it's not working for some reason. Oh, maybe because I'm in the browser or something. Let's see. So in this case, that will be pointing to 2. Now our previous node, we can set that to current. Well, first actually, we already updated the next node, so now we need to update the pointer instead of going to. So since we captured the next pointer to 2, we can break it, right? So we're actually gonna point next to previous. So because if you think about it, technically this is what we want to happen. Right? So our previous right now is none. That's why we're setting the current next to none. The reason we're capturing next is because if you overriding the one's next pointer, we'll lose this value. That's why we need to save number 2. All right. Now what we'll do is we're gonna set the previous to the current one, right? Because we're gonna be moving to the next one, so our previous is gonna be 1. So we're setting previous to the current pointer, and now because we need to move forward, we'll turn current to next. And as we go and run through this, eventually current is going to be none, but we don't want to return none, right? We'll get to here. We want to return the previous right here. So if we return previous, all right. So this is going to be in terms of time and space. We're just using 3 variables and we're running through all the nodes once. So our time will be O(n). So n is number of nodes. And then space is O(1), because we're only using variables, 3 variables here. So it's constant space. All right, let's. This is like a classic problem that you're not gonna probably be asked this at the interviews. Like I said, they used to ask this in Microsoft like 10-15 years ago. But if you cannot solve this, you need to probably practice more linked lists. So let's go to merge 2 sorted lists. All right. Just another. This is an easy problem. There's a harder version of this, but basically you're given heads of 2 sorted lists and you want to merge them into 1 list in order. So as you can see, this is list 1, this is list 2, and they want the whole list in a sorted order. So what we can do is, in a lot of problems where you're working with linked lists, you want to have some kind of dummy node. Why? Because eventually when we traverse through all the linked lists and everything, and put them into 1 list, we need to have some kind of reference to head that we can return, because they want you to return the head of the merged linked lists. This is 1 right here, is the head of the merged linked list. So what we can do is, let's see. I have like Vim bindings enabled, but let me just reset this. All right. So we'll create a dummy node first, and then dummy node will be a reference when we return the head node once we merge them, so we know where the head is. But we also need a current node that goes through and keeps track of the next pointer where we need to insert the node from one of the lists. So we'll use dummy node and current node, and the value of them does not really matter because we're gonna return the head will be the first link node, which is going to be coming from one of these lists here. So the value does not even matter. But by default in Python, if you set to equal to 0, it's going to be set to that. So what we can do is we want to keep going through lists as long as there's values in each list. And actually our base case might be maybe one of the lists is missing, right? So let's see, always check the input they give you here, the number of nodes. Oh, yeah, so it might be 0 nodes, so we need to do a check, right? So if list 1 does not exist, then we'll just return list 2. And then if, I'm not sure what's going on with the spacing here. All right. So, and if not list 2, we'll just return list 1. Because if either of them are none or empty, we'll return the other one. And if both are empty, well, it doesn't matter. It's gonna be none, right? So we got this dummy node, we got the current node, And then right now we're just going to be going through all the list 1, list 2, as long as there's values there. So while list 1 and list 2. So this is where we're going to be checking if value in list 1 node is greater than or less than value in list 2, because we want to return one unified linked list in order. So for example, if list 1 value is smaller than list 2 value, they'll know that list 1 value is the one we need to link to next. So if we have a dummy and current node, our current node next, right, because it's just a pointer we're going to be using to traverse. So our current next will be list 1. And then we also want, so for example, we grab the value from list 1 and link it in current, but we also want to traverse and go to the next node. So we need to update list 1 next. So we traverse to 3. Then otherwise we'll do current next list 2 if the value in list 2 is smaller than list 1. And we need to do the same thing with list 2. And here outside the ifs in our while loop, we need to update our current pointer, because we already have next, it's already linking to one of them. So now we need to move into it, like access that node and link next to another node, right? So just need to increment that step. So once that's done, the issue here is, let's say they're different size. We ran out of nodes in 1, so there's still nodes in 2. So we need to check that as well. So what we can do is, if not list 1, they'll know there's only values left in list 2. So what we can do is current next we can link the current next to just list 2, and then if not list 2, we can just link it to list 1. And then the current right now, let's see, so we start, let's say, with null, current next list 1, then we traverse to list 1, current, boom, boom. All right, so at this point, current is going to be pointing to either list 2 or list 1. Let's say it's around right before, let's say. But we don't know what the first node is, right? We cannot just return current. That's why we have the dummy node, because we know the dummy node is going to be pointing to the same list but from beginning. But our first value means nothing, right? So we'll just return dummy next. Okay. I'm trying to make the font bigger so you can see on YouTube. So this is also going to be interesting to analyze. Let's see, a runtime. So what is the time here? So the time here is, we need to traverse through list 1 and list 2. So let's say list 1 is n and list 2 is m. So we'll need to go through all of them. All right. And space is gonna take up as much as there's in list 1 and list 2. So also n plus m. If none of that made sense or parts of it didn't, leave a comment, let me know. All right, let's get to the next one. All right, design linked list. Design your implementation of linked list. You can choose to use a singly or doubly linked list. A node is a singly linked list, should have two attributes: value, next. Val is a value of current node, and next is the pointer reference to the next node. If you want to use a doubly linked list, you will need one more attribute: previous, to indicate the previous node in the linked list. Assume all nodes in the linked list are 0 indexed. And then they show you which functions we need to implement. So this problem, it's like pretty straightforward. The issue is it's a lot of code to implement, so it's very easy to make a mistake. Well, let's see what happens. So we do want to use previous doubly linked list instead of singly one, because we want to also capture, like for example, if we need to delete a node from the end of the list, we don't want to traverse through the all the items, right? Let's say there might be like 1,000 items in the list, right? And so on. Let's say there's like 1,000 items. So if they want you to delete index, like a deleted index, like 900, you don't want to traverse with next in the linked list over through all the items. What you want to do is calculate the index from the back and traverse from the back, because it will be easier to traverse from the back if the item is somewhere in this right half versus the left one. You'll see as I implement it. So first we'll need to create like a linked list node that will have both next and previous attributes like they mentioned. So value, say by default, you can just set it to -1. Next none, previous also none. Oops. So if you want to assign whatever be passing, by default it will be none. So to be able to access the nodes from the right side, we do need a tail node as well, not just head. So we'll create 2 nodes here. And tail as well. And initially you don't want to have any items, so the head and tail will be linking each other. And then say self tail previous will be self head. So if you want to picture it, it's basically right now by default value is -1, right? So we have head has value -1, tail that has value -1. So the way it will look like is, let's say we have a node, right, -1, that's head, and it's linking to node that's tail, also -1, And this tail using previous attribute is also linking back to the head. And then once we start adding items, let's say we add one, it will look like this, right? Both head and tail will be pointing to it, for example. So that's kind of the idea. This is head, right? And this is tail. They have dummy values -1, which we won't care about. All right. So, what is this? All right. So, let's see. Do we need to track of the number of elements we have? Of course we do, right? Because we need to figure out, get the value of index in a linked list. If index is invalid, -1. We won't know if the index is invalid unless we store items here. Let's go. So we'll just have size, and initially it's gonna be 0. Head and tail won't really be counted as values. They're just dummy nodes, basically. All right. So to get the value of the index node in the linked list, if the index is invalid, return -1. Okay, and they also told us that assume all nodes in the linked list are 0 index, right? So this would be 0 index. So we need to do a check. If index is less than 0, or if index, so let's say our size is 1 and they give us index 1, that's an issue because one item is index 0. So we can say if index is greater than or equal to cell size, that's an issue, return -1. So here's the thing. We don't want to keep writing get method over and over again, because like even here at index, at a tail, delete that index, we'll need to get the item at that index. So a smart way, like when you see that you'll need to use get several times, is to implement a helper function. So we'll create another helper function that will be responsible for just getting the node. Here in the get, they want to get the value of that index. So what we can do is use our helper function to get the node and then just extract the value. And they'll do the similar things with the other ones if they require get. So I'll just write a helper function. Let's say get node. And then we'll pass the index. Now we don't need to check the index here because our get is already checking that the index is either less than 0, and it will return -1, right? So in this case, self get node. I'll implement the get node in a second, but and then we'll pass the index. And since we'll be getting a node, get itself, we'll get the node from the helper function. Get itself will need to extract the value. So we'll use val for that. And we need to return. Yes, insert mode. So the get node is probably going to be the most complicated logic in terms of if you want to traverse from the back or the front. So what we can do is we want to figure out, do we want to start from self head or start from self tail, and how are we going to do that? Well, let's say our node size is 1, 2, 3, right? So self size is 3 here. So let's say they want to get node from index 0, right? We know that index 0 is closer to our head node, right? I just visualize it like this. They'll also have a previous node, don't forget, right? So technically it will look like this. Right, so if index 0, obviously index 0 is closer than head to head, right? But let's say it was index 2, that would be closer to tail. So we wouldn't want to traverse from here all the way here. We will want to start from the back. So how do we figure that out? We need to do some math. Yeah, let's do some math, right? So first of all, let's have a current node that will traverse through the array. So in this case, what we can do is if, for example, our index is smaller, then we'll take the size and divide it by 2. So for example, in this case, index is 0, and the size here in our example is 3 by 2, it will be 1. So if 0 is less than 1, we know that index is closer to the head. Where, like, let's say index was 3 or 2, but the size is 3, then we know that we need to go to a different case starting from tail. It'll be more clear when I do it. Let's see. So basically, if our index is smaller than the whole size of the linked list divided by 2, we know that the index we need to extract is going to be closer to the head. So we'll start from self head. Otherwise, we'll start from tail. Now we're getting so it could be index 0. So we can just traverse using for loop. So if index is 0, we don't want to start at self head because it will skip it. So let's say we'll start at next. So whatever is pointing to next. And then we'll just traverse. So if index is 0, it will traverse 0 times, but it will be pointing to the 0 item. If the index is, let's say, 1, we'll start from item 1 and traverse 4 once. Okay. Now the tail is going to be a little bit more complicated because we need to compute how far we need to go down from the index. So let's say, let's take this example here. So let's say they want us to delete index 2. We go into this if else case. How far do we need to go from our size to access index 2? So what we can do is just subtract it, right? So for the range, let's do self size minus index. So we know the size is 3, for example, index is 2. We go to this else case, right? Based on this calculation, size 3 minus 2 we'll need to traverse once. So if we start from tail, this will go from tail to 3. But in this case, we're going the other direction. That's why we need the previous pointer. And then at that point, I think we just return current. So instead of doing this calculations and rewriting this code like in delete index and stuff like that, it's good to have that helper function, right? So let's see, add at head. Add node value, the first element. After insertion, the new node will be the first node of the linked list. So we can just say, we can just pass that to add index, but self add because we're going to be implementing add index function, so might as well pass it instead of rewriting manual code. In programming in general, right? Dry method is do not repeat yourself, otherwise we would have to write all of this out in every function. Now add a tail, append node value as the last element of the linked list, and then let me see, add index, add node value before the index node. If index equals to the linked list, the node will be, so at add index, if the node index is equal to the length of the linked list, the node will be appended to the end. So then we just can say add index self size, because that will be the end in this case value. Now add index, add a node value before the index. If the index is equal to the length of the linked list, the node will be appended to the end of the linked list. So we can do some checks here first. If index is less than 0, that's not valid, or if index is greater than self size. We'll just return, because if the reason we're doing index equals to self size here, because we're allowed to we're not allowed to have get, right? We cannot just get index 3 if there's 3 items, because it's 0, 1, 2. But in this case, we can add self size. All right. Also, before I forget, since we're inserting at the index, we need to update our size here and make sure when we delete. It's a very easy mistake to make in such long implementation. Already 50 lines of code basically. All right, add the index, add node value before the index. So before the index, so we'll retrieve the index using our helper function. Next node and we'll just do self get index. I'm just thinking if, yeah, let's just, I'm just thinking, okay, if what if, so what we can do is, let's say, if index does actually equal to self size, we want to add that, right? So that's like a corner case. So what we can do is just, in this case, first of all, we need to create a node. New node is node value. And then in this case, we can just get, what is the previous node of? So, okay, that means we'll just end it at the end. So, and this is a corner case, right? If the node will be appended to the end of the linked list. So we'll just do new node previous whatever tail is pointing to right now, previous, and then new node next is maybe going to be pointing to tail, and then we need to update self tail previous. Easier. So we need to update the previous now to point to our new node, and then self tail previous will be pointing to a new node. But basically, yeah, so like, let's say we have 2, 1, 2 linked and tail right here, right? If you want to insert at the end, this node, right, we need to update all the pointers. Just sit down and draw it out, and you'll see why we need to do that. All right. So that's like the corner case. Else, we'll just we'll use our helper function. Next node, basically. Let's get the because it says we need to add value before the nth index, right? So we'll use the get node to get that value at that index and then relink it. So in this case, we can do the same thing. New node next will be next node. New node previous will be whatever next node previous is pointing to. And then we also need to update the nodes to point to the new node. So new node previous node next will be this current node, and then next node previous will be linking to this new node. All right, let's see. Now we just need to implement deletion. So delete an index if the index is valid. So we can double check. We can actually even write a helper checker function to see if these indexes are helpful or not. I mean, valid or not. Or index size return. That's not valid, right? So we can just get current node that we need to delete. And then we can just delete it by linking the previous node to the next one. So current node previous next will be current node next. And then current node next previous will be current node previous. And then we can also do this. I don't think in Python it's that necessarily, but just resetting the, like for garbage collection or whatever. I don't think you have to even do that in Python, but let's see what happens. Why is it not? Boom. Oops. Boom. In one go. That's dope. I mean, the thing is, it's like, it's not a super hard problem, but it's so easy to make a mistake. And the fact that I was able to implement it 25 minutes also with explanations. So obviously if I didn't have to dive deep that far, I could have solved it faster. But yeah, the fact that it compiled from the first time, pretty happy about that. Anyways, I have a meeting to go to, FANG company meeting, so gotta go, but hope you enjoyed this.